according to the plan. And with that, welcome to a guide to developing cross-platform mobile apps for IoT devices with our speaker, Poojita Garg. Poojita will walk us through, and oh, I think I pulled the wrong thing. I pulled the description of the talk and not your bio. Sorry about that. Poojita Garg is a computer science graduate currently working as a research intern at Georgia Tech with over 2 years of experience developing mobile apps for IoT-enabled devices. She has authored several research publications and has been granted a patent for one of her inventions. She's also a passionate advocate for women in technology and serves as a track evangelist for Women Who Code Mobile, and we are so lucky to have her, and a track lead for Women Who Code Python, and they are also so lucky to have her. When she is not a techie nerd, she is learning a new language, playing notes on her guitar, or dancing on some beats. So with that, if you have any questions throughout the talk, feel free to drop those in the chat and we'll have some time at the end. You can also drop them in the Q&A, and over to you.
Thank you so much, Sarah, for a wonderful introduction. And I'm really glad to be part of our Women Who Code community. So, okay, so with that, I'll just share my screen. Let me know if you are able to see my screen like nicely. It's not.
Yep, we can.
Okay. Okay, so let's begin. Okay, welcome everyone. So I'm really excited for today's talk, which is about developing cross-platform mobile apps for IoT devices. So we'll be using React Native, Firebase, and Google Sheets. So it will be an easy starter's guide. So don't you worry if you are just beginning or you're just a starter in this cross-platform mobile apps. So Sierra has given a wonderful introduction of mine, but just a few things. So I'm Poojita Garg, as you know. So I'm an engineer, developer, and researcher. So I'm currently research intern in Georgia Tech, and I have graduated BTech in computer science engineering from India last year. So I've authored 4 research publications and a patent grant. And again, I'm so lucky to be a part of a Women Who Code community. Okay, so before starting the talk, just where you can get the materials. So this is the GitHub repo which I have created for, which will contain all the code which we'll be discussing today. You can also scan the QR code to have a link directly to the GitHub repo. Okay, so let's just begin. We'll begin with a brief introduction of the tools we are going to use. So as mentioned earlier, we'll be using Firebase. So if you have heard of this, it's very popular backend as a service by Google. And so it provides different services. And today we are going to use one of its services called real-time database. We'll be using AppScript, which is again another service. It's a scripting platform developed by again Google for lightweight application development. The others would be React Native for cross-platform mobile application development, and Google Sheets, which will serve as a database for today's session. So it will act as a cloud database. So just quickly, what you should know and what new we are going to learn today. So we will not be discussing any basics of React Native app development because that's what I assume that you all know. We will also, I also want you to know the basics of coding hardware if you want to. So it will include Arduino coding and the Wi-Fi module, using the Wi-Fi module, etc. And because I'm no expert in that, so I would not like to discuss that. But I have given a useful link in the presentation, which you can use, which you can refer. It's a Arduino documentation on how to code hardware.
Hey, Poojita, can you go back to the materials link? Sorry, I was posting our Slack links. Okay, great. And then just. Okay, great. I can share that in the chat. Thank you.
Okay. No problem. Okay, yeah. So what new are we going to learn today? So creating mobile apps for IoT devices. So would essentially need three things basically, and three connections between them. So first would be connecting our real-time database, that is our Firebase, to our mobile app. The second would be the connection between the Google's app script and Google Sheets. So Google's app script will basically code something in Google's app script, which will automate our Google Sheets. So that will basically help us save the readings onto the Google Sheets. Lastly, we would be looking into how to connect our Google's app script, okay, to our mobile app. So first we are going to like deploy our Google's app script as our API, like as a web app. And then we are going to, use it like in our mobile application to make a connection. So hope that's clear. So let's dive right into it. So first of all, what is IoT? So to all those who are curious or haven't heard a lot about IoT, it's an acronym for Internet of Things, which is a system of cross-connected wireless devices with access to internet. So these devices can collect, send, and act on data they acquire from the surroundings and the environment, or share among each other. So it is possible due to they have like the embedded sensors, they have some processor to process the data, and also due to the communication hardware that may include your Bluetooth or Wi-Fi. Okay, so but how are IoT devices and mobile apps related? So I hope you might have used some IoT based apps, like if you have a smart home type system, like if you want to, switch on and off your AC or increase decrease temperature from your mobile apps without a remote or something. And also that will work when you are in the next room or even when you're on the way coming to your home. So these things are like how IoT devices and mobile apps are related. So mobile app can serve as a medium between your IoT hardware, which is the IoT device, and your mobile phone. So since it's a mobile phone, it will, be like you can have like remotely monitor that particular IoT device. So the app works as the primary interface through which you can manage these smart things. So a few examples of these could be, your fitness trackers, your smart home, so your Google Mini, Alexa, all use such kind of IoT technology. Also, there are some smart cities being developed or are in progress, which one of the example is that some cities, they have started like having street lights, they go on and off depending upon the traffic to save energy. So that's one kind of example. Other popular and very crucial one is in healthcare. So you are getting, these equipments in market, which the patients could use remotely from their homes only. So they are very user friendly. So they have this certain equipment, let's say it can measure your blood pressure or something like that, or even diabetes, right? So they will measure it, and they have a system, they have a sensor which will measure your reading. They have a communication medium which may use like Wi-Fi or Bluetooth, which is connected to your app on your phone. So the device will measure that reading, and it will show in a real time what the reading is, or if you want to save it, it can save it for you. So before we go in what we are going to learn exactly today and all the code stuff, let me talk about like a case study, which is my own case study. So remember, like Sarah also mentioned that I have a patent for one of my inventions. So it's exactly this invention. So me and my team at my university, which is Punjab University in Chandigarh, India. So we had a group, research group, basically, Design Innovation Center, where we created this motion sensing glove for physiotherapists. So that is, I will, show you the image. So basically, where our collaborated doctors, they give us some, some demands. They were demanded us that they wanted a device which could easily measure the recovery of patients who were undergoing hand physiotherapy, because the earlier the existing process which they were using was slow and was very manual. So you can see an image on your screen. So this is an electronic, not an electronic instrument. This is a manual instrument, which is called goniometer. So they were currently using this, and to measure the hand finger joint angles to check whether the patient who has some hand injury is recovering or not. So we wanted an automatic system. So for that, we created this IoT based motion sensing glove. So this is a prototype image, and here you can see that there are different sensors embedded on a fabric based glove. So this is where the sensors would work, and they would sense the readings of the hand. But that's not enough, right? Because a doctor is not an engineer or won't like care about how they are accessing, how they want an easy way to access readings, which is time efficient as well. So what we did was that this is the hardware, okay? You can see in the first image that there's a glove, which is the hardware. It will transmit the readings via Wi-Fi, so to increase the range of transmission. It is using Wi-Fi. Then we want to show the readings on an app. So it will be a very user-friendly interface, which the doctor can operate easily. So, but to do that, we need a bridge between. So we chose Firebase, which will collect those real-time readings. Again, there will be a mechanism where we could, from the phone, we could fetch these real-time readings. So after fetching these real-time readings, we also want them to have a mechanism of saving them for future retrievals or for data logging purposes. So there we used Google Sheets, which is again a very user-friendly way for them to check later on. So it will be stored on Google Sheets. So this was the complete flow. So since these are not just the functions which the doctor might need, we added other functions as well. Like we added a mechanism to add new patients, like a complete patient database also, like to add new patients, manage the accounts of existing ones. Okay, so displaying sensor readings was the primary objective. And then also like insert graphs of the recovery curve so that it can be easily, the recovery could be easily monitored. And all the other patient data and other stuff could be added. So these are few slides of few screenshots of the app which I created. So because there were many readings, so it was in a tabular form. Then adding patients and having the recovery curves. So advantages of the product, which it was really advantageous in terms of it decreased, significantly decreased the time taken to measure the recovery, thus impacting care for more people. Then also because we wanted to make it like elder friendly, like something which the elders could actually use, that user friendly. So we added a remote monitoring capability in the system where just like a diabetic machine which your grandparents or your parents might use at their home and then send the readings directly to their doctors, we added something like that if a patient wants to buy and has to go to frequent clinic visits, they could buy the the glove. They could have the glove and their associated mobile app together, and they can use it at their own comfort in their homes. And then there's a way for the doctor to like remotely monitor what the recovery is. And especially it's useful for these time we are living in, the COVID-19 pandemic time. Okay, so that was a lot, right? So let's start with something basic, something very easy to start with. So the major things here to take care is the connections between these different basic three different like structures or the pillars, which is the Firebase, where we are using the real-time database, your mobile app, how it is connected to Firebase, and how we are sending our readings to Google Sheets and automatically saving it from our app. So these are the three things which we're going to discuss in detail. But just for we are able to understand these connections well, let's talk about a simple app to fetch humidity and temperature readings. So you might have these things we check every day, like what would be the temperature today or tomorrow. So we'll just start with that. So just to give you a glimpse of what the hardware looks like. So this is the humidity and temperature sensor, one of the kind. And so this is how it looks like. Here, this is, I have given even the source of it. So this is an Arduino documentation on how this is a Wi-Fi module, how we are connecting a Wi-Fi module to your Arduino, which is your microcontroller, and then coding it to connect it with Firebase. So a little sneak peek into what we are going to build today. So on the right-hand side, you can see that there's a mobile app chip. So here you can see that I have not really made its UI very fancy or something. It's a very primitive UI just to showcase the major concepts well. So we have just the temperature, humidity readings, which are changing in real time as I change them in Firebase. Then hitting the save button, these readings would directly be saved to our Google Sheets, which would look something like you can see on your left. So it is again a simple Google Sheet, like where you will be saving a timestamp with that temperature and humidity readings. Okay, so let's start with the first step, which is setting up a real-time database with Firebase. So this is how your Firebase console would look like once you log in with your Google account. So after hitting that plus add project button, you just create a repository for your own project. After you've done that, you can see on the left menu that there are a few services which are included in Firebase. So we have to go to the real-time database. So once you click on that, there will be this kind of console which will pop. So this here in this console, you will create a new real-time database. So these very simple steps, a very user-friendly console they have in Firebase. So it's very easy to navigate. Here you can see that it will ask you for security rules. So they have two options. One is start in log mode, another is start in test mode. So you must start in test mode first for prototyping your app. Once done that, so this is how your real-time database would look like. So just a couple of things about the real-time database of Firebase. So it is not, it is a NoSQL database. So basically it stores data in form of JSON tree. So it will have a hierarchical structure, and each node is added with a unique associated key, which is auto-generated. You don't have to deal with it. One thing that is really important here is that in order to let your hardware access your database, you need to go in the rules tab of your real-time database. So earlier we were on data tab. Now you go to the rules tab. You just check if these read and write rules are true. If not, then please make them true. Next, since we're dealing with two sensor readings, humidity and temperature, I'm just populating this real-time database with two nodes by just clicking on this. You can see here, there's a plus, plus button. You just click on there, you add a node, you had its key, which is humidity, and its value. So just by default, you can put it as 0. So I've just created two nodes like this. So with this, we are over with our step 1, and we move on to step 2. So that is connecting React Native app to Firebase. So you can just start by creating a new React Native project. Also for this tutorial, we will be using Expo to build and test our application. So if not, you can install Expo Cleave using below code in terminal. And for this guide, we also be, just to avoid any complexities, we'll be just writing all of the code in app.js file. Okay, so set up Firebase in our app. So this could be, intimidating to beginners, but I have just, differentiated in 3 basic steps. So the first of all, there is a node package Firebase. So you just install it. Later, when you're starting to code, the first step you need to do is that you need to import the package you just installed. The second would be to create a Firebase configuration variable. based on the configurations of your Firebase real-time database. So you remember that in the console, you can go to the settings and you will find all these configuration values like API key, auth domain, and etc. So you just copy that from there and add it here. So you created this Firebase config variable. And the third step would be that you have to initialize this variable configuration parameter. So by this function, initialize app, and putting as Firebase config as the parameter, you will initialize this configuration variable. So this was all about, from these steps, your app will be connected to Firebase. But it won't still read, it won't show you the readings. For that, we need to create a Firebase event listener. So for that, I'm just using this, I have created this end user ref as a state variable, and I'm initializing it to be firebase.database.ref. So these are the these functions which will give you that database reference. So you see here that in ref, these are just blank parentheses. So that means that we are referring to the root node. If we want to refer to a particular node because it's in hierarchical form, so let's say I have to refer to some other node, not the root node, then I would have to put a path here in this ref. After this, the database reference is ready. Now you have to create an on listener. So this is the way you'll do that. Here we are using snapshot, basically. So this what event listener would do is whenever there's an activity or there is anything updated in your Firebase, it will reflect it, and you will so this will basically make you see any real-time change which is done in your Firebase. So everything, the data would be you can find the data in this snapshot variable. So this is the way I have created two local variables, data1 and data2. Where I'm accessing the temperature and humidity variables respectively from snapshot.well. Later, since we have to use these temperature and humidity variables later on in our code as well, so I have created them as state variables and then giving them values, setting their states here. Okay, so with this, we are almost done with our step 2. You just need to give this code a thorough run through, and just you will be done with at least connecting your code with Firebase. Now let's move on to step number 3, where we will deal with Google's App Script and Google Sheets. So first of all, you might have used it earlier as well. Go to Google Sheets console and just create a new Google Sheet. And then also, have these 3 columns named like date, temperature, and humidity. Later on, now what you have to do is that go to App Script. Okay, search that on your web browser. Go there, log in. Again, it's a Google service, so you just need your Google account. You create a new project. Now, AppScript uses a JavaScript-based scripting language. So it's very easy to use, nothing fancy. And just go there. There will be an editor open. Now, there, the AppScript specifically has to connect with the Google spreadsheet. It specifically has its own functions listed. So it's a whole good documentation by Google, and it's all listed. Few of them which we are going to use, I'll explain it right now. So first of all, we'll be having to fetch the spreadsheet, we'll use its URL. So this spreadsheet app.open by URL is again a function, a sheet function in the app script. Here you have to mention the URL of the spreadsheet which you have created in the first step. So you just copy that link, you put it here. The second reference which we need is that since a spreadsheet can have more than one sheets inside it, we need to reference that particular sheet which we are going to use. So for that, I'm using that once I had this var spreadsheet point to my spreadsheet using its URL, I will use this variable and use a function called getSheet by name and put the name of the sheet of that spreadsheet which I'm going to use, and which is in my case is sheet 1. Again, I'm referencing this into another variable, where sheet. Now, since our app, which is our mobile app, React Native app, it will be sending a post request to this API. So which we will create, like will be deployed as web app, and it will be created. Since it's giving, it is having a post request on our code. We want our code to deal it as do post function. And so in the function do post, I'm going to, do all the processing. Now it will take a parameter e, which will contain all the data which is coming us from a post request. So I've created these three variables, date. So I just use the date function to fetch the current timestamp. Then temperature, for temperature and humidity, it's the data which is coming from the app to us here. I'm fetching it using e dot parameter and then the temp and the keys of the data which is coming to us. Later, I'm using another sheet function, which is append row. So it will take the last row and like in the last row, it will append it. And this is the way of doing it. So I'm just appending row with date, temperature, and humidity. This is how in an array format it's written. And later I'm just returning it. I'm just returning like a success, so that, in our app, so that we get to know that, okay, the readings have been successfully saved, or if there was an error, it will also be returned. So in MIME type text. Okay, so well done, we are done. Deployed as web app. So here's a deploy. You can see this blue button at the top. So that's the deploy one. So just click that and you will be prompted with the dialog box, just like which you see on your screens. So here, once you hit deploy again, this will be deployed as a web app. But before that, if you see the last option, which it asks that who has access. Now, since we haven't given any permissions specifically for the app, we'll just for now say it anyone, so that our app could easily access this code of ours. So you need to remember that for the prototyping purpose, these steps are valid. But if you're going towards production level or something, then you need to take care about the security and privacy concerns as well. So you need to read about them as well. Also, after this, once you hit deploy, you will be prompted with a URL. So you need to copy that and save it, because that we will use later on in our code, React Native code. Okay, so the third step is that create a function in the mobile app to save the readings onto Google Sheets. So for that, in our React Native code, I've created a save readings function. And so in this, we are using a form data library, so which is used to submit forms and file uploads to other web applications. So first of all, you can just install the form data library and then import it. Later, you see that I've created a variable which is of type form data, and there in the body, which is body data, and in body data, I can append any of my data which I want to send from as a post with my post request in key value pairs. So this dot state dot temperature is my value, and this temp is the key. Remember that this temp and hum is the ones which we were using in e dot parameter dot this temp and hum. So these need to be exactly same. In the later part of the code, to actually make the post request, we're using the fetch API of React Native to connect our mobile app to the remote URL of the app script. So here also, yeah, the URL which you saved earlier, you need to paste it here. Again, the method is post. The body would contain our body data. And so the fetch fetch method will return us a promise, which we can get using .then and catch the response in our variable res. So if it is success, which we sent it if it was a successful operation, then we are using alert to create an alert dialog for the user to let them know that, okay, great, your readings have been saved. If not, then we are just logging the error. Okay, so with this, you are absolutely done with your project. So you use Expo Start to run your mobile application. And if all things work nicely, you might, you will have this amazing app where you can play with it using, like, have Firebase open on one side. You can have your Google Sheets open on one side and app on your Expo client on your phone, and you can just play with that, like update those readings. You'll see them on your phone updated, and you save them, and they will automatically be saved to Google Sheets. So with this, thank you so much. And again, you can find the code. Sierra must have posted it as well. And if you want to find me, I'm available on Twitter. And this is on my website also, and you can know more about me there. Any questions?
Thank you so much. AppScript is really cool. I feel like I tried to integrate Google Sheets many years ago and decided it was too complicated. And this looks like it would make my life substantially easier. I don't really remember what that project was, but I gave up and decided not to go that way.
Yeah, no, it's easy. It's easy. Once you get a hang of it, you get to know how to use AppScripts well. It really makes your life easier.
We do have time for questions. If anyone wants to drop a question in the chat or the Q&A, we have 2 in the Q&A, but you have some time to think about it and ask away while we're here. So the first question is, what are the benefits of using Firebase compared to AWS IoT?
Honestly, I have not used AWS IoT, and so I won't be the best person to compare the both. But I really like Firebase. It gives you a good platform to use any of the other services, like it has Firestore and other services. So I think I really like Firebase. I won't switch, but again, I have not used AWS IoT, so I can't compare.
Built-in functions .append row comes from JavaScript or any node package to install to get these functions?
No. Once you're using this app script, okay, so it's inbuilt function in the app script. So you need not do any installations in your app script project.
Awesome. What challenges did you come across code-wise, and how were you able to navigate and solve these?
Is this talking about the case study or like this tutorial which I just mentioned?
We'll let them add any notes. The tutorial.
The tutorial, yeah. So since I've been working a lot with Firebase and other technologies, obviously there were initial challenges, but once practice, you get to debug them very easily. So I don't actually recall any of them. It's been a while. But I think if you follow these steps which I mentioned, and you can also have a look on the GitHub repo, you might not face any challenges as such. I've tried to keep everything as simple as possible. Also, I have also written a blog and explaining like each line of code in that. You can also have a look there. I'll just find the link to it, and then I can share it in the chat. Sure.
Are you ready? I wasn't sure if you're still looking for the link. I didn't want to bombard you with questions while you're.
No. I'll do that side by side. No issues. It's open actually.
Can you explain more about the Wi-Fi connection?
Yeah, so basically Wi-Fi connection is not anything related to like I don't know, I haven't like Wi-Fi connection in terms of coding hardware, right? So that was one thing which I kind of I'm no expert in that actually, because I haven't done Arduino coding. So the source, I'll share this PPT or even in the blog, you can find that. So I have given the source, which is Arduino documentation itself on how to connect Wi-Fi and Firebase with your microcontrollers. So I think that would be your best take here. I won't be able to answer that.
Can we connect with other services like Google Docs or Drive to this Firebase?
To this Firebase.
So I think that question might be that you're using Google Sheets. And so can you use the other like Google workspace products in the same way?
Yeah, I think so. Like the major thing here is that to use app script. Like I have found over the years, like it's the best way to create your own custom API. And so you need to think, you need to like sort of a little research a little about what are the appropriate functions to use. But I definitely think that we can, connect other things as well. Like I know definitely about Google Sheets, but you might need to find in the documentation if there is a method to do that.
I am clearly not an expert, but I was looking at AppScript when you brought it up, because I thought that was super cool, because I remember that painful experience, and it did look like you could like query other projects, but that was a 2-minute investigation while you were talking.
No, definitely. I think Google has a really good connections between its products. So I really like that, a seamless connection between the products. So I think there would definitely be a way, but I genuinely haven't tried it, so I don't know. I've posted the link of the blog. I hope that's useful too. I've tried to keep things very organized and as simple as possible, since it's a starter's guide. So I hope you also like that.
Yes, and Poojita also does a lot of other writing. So if you're interested in publishing research papers and some of her other posts, she has many others that I would definitely recommend checking out as well, to look into the other aspects of her very active life.
Yeah, you can find everything on Medium, like all the blogs which I've written. Yeah.
Any other questions before we wrap up? Really excellent questions, and want to call out this comment in the chat is, thank you, you are awesome, and I could not agree more. So
thank you so much everyone for joining, and thank you Sarah for hosting me.
always. Okay, so no other questions have come in. I just want to thank again Poojita for speaking today. Thank you so much for sharing the work that you did with that project and how to get started as an individual. That was awesome. And thank you all so much for taking time out of your day to come and join us. Again, we would love to see you in the mobile Slack. You can talk to her directly there. And also following us on all our different social medias to stay up to date with our track and the upcoming events. So again, we're having an event on Tuesday, just in a couple days, and then more events upcoming and being announced all the time throughout the year. So thank you all so much, and have a great rest of your day.
Yeah, thank you, Sarah. Thank you, everyone. Bye-bye.